All right, take 3. Let's see if we can get a video on interoperability and extendability in the electronic lab notebook. So I'm going to show you today the idea about how we want our notebook to be able to interact with other things on your computer, other instruments, and why we would want to be able to extend our notebook in a variety of ways, and things that we might want to have as features. So in this little inset here, you can see a little USB device. It's a Adafruit playground, and we can program this to do a bunch of possible things. And so it's currently we can see, I can put an overlay in here so you can see a live feed. Right, that's my hand. There are some white circles. These are LEDs that we can light up, and it is currently programmed so that I can press a button and see a light come on, or press this button and see that light come on. And this device is run by a program, so when I plug this in, it makes a little device on the computer. And it is located at volumes, for me anyway, circuit.py or circuit.py, code.py, and it's just a little Python program that runs on here. Now you can change this, and for example, I could make this be 2. And when I save this, you see a little flash on there, and now you might recall that this LED used to light up, but now this one is going to light up when I press that button. All right, so we have a little bit of a challenge here in documenting what code was run, and then how do we capture those results in our notebook. So I'm just going to copy this code here. And we're going to start using an idea from literate programming, where I can have this Python script here, and I'm going to put a tangle header here, and we'll navigate down here, circuit.py, code.py, and I'm just going to pick the absolute path. So this is a concept in org mode, in literate programming more general, that I would want to be able to tangle this content of this cell over to that path. And one way we could do this here is with org babel tangle. So I'm going to use a prefix arg. Let me show you why. Org babel tangle. Oh, maybe we can just do this. Let's see if this is interactive. Org babel tangle. It isn't. So I need to run org babel tangle, and we're going to use a prefix arg that will make it output only this file. So here we have 2 and 7, and I'm going to make this just be 1, and cv tangle. This says that it tangled 1 block, and over here you see this changes to 1, and now you can see that we're back to 1. And if I make it 0, then it blinks again, and that makes that 0, 1. So this is 0, 1, 2, and I can change it back to 2. Tangle it out, and once it gets a little bit of time to restart, then we have that working like so. Okay, so this is a way for me then to, in my notebook, keep track of different versions, and so let's put in a heading here, LED example. All right, and let's say no buttons pressed, button A pressed, button B pressed. So what we need to do now is think about how do we capture what information is available here. And there's some manual thing, right? When I push this button, this is happening outside of my notebook, and it's like pushing a button on an instrument to start, and similarly here, and so we have these different states. So one way we could do this is just to capture an image, and this is an idea that I have written into scimax. So I bind it to F10, and this is going to run a screenshot, and it is pretty specific to the Mac. I use an Apple script here to just set a screenshot, capture it, and then output something. So on a different computer, you'd need a different solution to interface with your favorite screenshot tool. But for me, I'm just going to press F10, and then I'm going to capture a image that shows what it looks like with no buttons pressed. Okay, and this is an image. It has some value because we can literally see what the device is, what it looks like, and I can go down here if button A is pressed, and that lights it up, and now I want to capture that, so I'm going to go ahead and do this and capture that. And this has the benefit, I think, of showing where my finger is and what the rest of the board looks like. And then similarly, we might have down here, if I press button B, then I can also capture what this looks like. And now we have a record of this particular experiment. Very simple experiment, and not a lot more to it than that. Now there are some other experiments that one might do, and let's see if I can find them because it's going to show some other challenges that we need to figure out. So let me see. Let's see. Playtone buttons. All right. So now let's do a sound example. And to make this one work, we just write a new program. And the new program is going to look like this. And let me copy where we want to tangle it from, because we just update the tangle path. Or we just update the code. And again, we could write it in here and it would work, but I'm going to just tangle this, Control U, CVT. And that's going to update this. And now, if I press this button, you should hear a little sound if the mic works. And if I press this one, you'll hear another sound. And they have slightly different tones. Hopefully you could hear that. Let me turn off the fan and see if that helps. Just in case. Yeah, okay. Now, this is a new challenge. It's easy to take a snapshot of a figure, of a screen or a window, or paste an image in, but now we're going to be stuck trying to capture a sound. And so here we need a new idea. So let me again say press button A and press button B. All right, so here we would like to be able to capture some sound, and that is actually something I have also written in through SEM edit marks. We can create an edit mark, which is a special kind of object in scimax, and hopefully if the microphone again is good enough, then it will record it. So I'm going to press, I'm going to start here, and this is a key binding to insert an audio. Let's see if it works. Let me show you the idea first and make sure it works. So when I press A, it's going to start recording, and you see this thing going off on the right, and it says to press Q to quit. And then that inserts this link. And if I have the cursor on there, I can press enter and it'll play it back. And you see this thing going off on the right, and it says to press Q to quit. Okay, so that allows me to capture audio notes, and I'm going to try that here to capture what happens when I press button A. So again, this takes a little bit of coordination because I have to press these buttons and do this. Maybe there is a way to automate this in some other instrument. The main idea here is I'm able to make this work even though that's not automated. Okay, so I can just move this. This is just plain text, so we can just move it around. And here I'm going to play it. And I heard a couple of very light beeps on that. And down here, I'm going to do it again. I'm going to press A. And then have that saved. So I'm not sure why it is inserting it up there. That seems a little bit buggy to me, but let's listen to this one. All right, so that's me recording audio. I never figured out exactly how to record video by this method. This is just automating some aspects of QuickTime, I believe. And let's see what, it's actually using a program called scimax, not QuickTime. So this uses a program called scimax where it starts scimax in a recording mode and then uses Q to quit, and then it is inserting a link to the file. And we can see that we have created some files in this directory. So these are the 3 MP3 files that got created, and they're missing a lot of metadata that you might like associated with it. Again, the metadata is the document that it is stored in, and you'd want to put some text around this so you know what these things are. Now, I think what's important in this idea of extendability is that this functionality did not exist in Emacs out of the door. Of course, I can record something and then I can insert a link to it, but the ability to couple all of these into one environment where I have my notebook able to launch a recording device or do something manually and then take pictures of it down here. The ability to show what the code is that is on this instrument at the time when I ran it. Of course, I'm relying on a convention here that I follow this document from top to bottom and execute it in that order. So if you do these things out of order, it's not going to make sense. No notebook can really compensate for bad habits like that. And if it does, it will limit you, and you won't be able to do this kind of thing that I've shown you here at all. So those are the kind of ideas I wanted to get into today. Just what kinds of things are easy. The biggest limitation right now is an automated way of creating a video. It's not impossible. Like you've seen, there's a video stream right here, and this window is not in my notebook. It is just an overlay. Maybe if I shrink it, it'll be more obvious here that it's just an overlay in OBS. It's not actually getting captured. But you could probably, this is just running in QuickTime, so maybe I can figure out a way to record this to a file. Actually, I think I just click on record here. Let's do this. So I think that is recording now. And I can click on stop, and somewhere is untitled movie. That's going on my desktop. Right, and then I have to kind of manually move that video over here, and then I can make a link to it like this. And I think I have to switch. Let me switch to the desktop view, and you can see a little bit more clearly. So here I have made this video link. If I click on it, it will open, and then I can play it. It doesn't look like it captured sound. So it doesn't help us in this case, but that's probably some fault of my own for not having a sound capture on there. Yet another example of how you want to make sure you try and test everything before you rely on it to have worked. So I think there's possibility to get an automated video in here. I've been looking at something called Hammerspoon for a Mac, and I'm pretty sure I could make Hammerspoon automate QuickTime where I could tell it to start and have some mechanism to stop it later, and then save it to a file and move it and make a link. That all seems very, very possible. But it's a low priority for me at the moment because I don't normally need video. Usually we want data files and or images. So I'm going to see next week, we're going to look at some other kinds of instruments where we can get some actual data from it. And it is possible to get data from this one. It's just a little involved and not how you would use an instrument most of the time. But I think it'll be interesting to play with this and another Arduino device to see how this notebook interface can be used. All right, that is all for today. Thanks for coming, and next week we'll hopefully see some new kinds of instruments and